in motion? Yes, anybody?
When it changes
when it changes what?
Its position.
When it changes its position. And so the big question is, what is motion? What is motion? Anybody? I have 9 of you. Benedict, what is motion? Godwin, what is motion? Whose hand is up? Gerard. Okay, Gerard, go ahead.
So please, motion is the change of a body within time.
Change of what?
A body.
No, Gerard, I will not buy this. To say change in a body, no. Something is missing. What is motion? Andy, what are you saying?
So I'm trying to explain.
Try.
The motion is the continuous change in the position of an object.
Motion is a continuous change in the position of an object. So, please, the first responder, it is not change in body, but you must talk about change in the position of the body.
I want to say something.
Okay, go ahead.
Motion is if an object changes its position with respect to its surroundings with time.
Exactly. So its motion is about change in position of a body, okay, within space with respect to time. You cannot claim to be in motion when you are standing at the same place. Now also that's okay. So for a body to be said to be in motion, its position must change, okay, within its space with respect to time. Now, can a body be said to be in motion when its speed or velocity does not change? It's a question to the whole house. Can a body be said to be in motion when its speed or velocity does not change? For position, we've just seen that it's a must that for a body to be in motion, its position must change. But can a body be said to be in motion when its speed does not change? Who wants to contribute here? Nora, over to you. Nora, answer this question. Nora is gone. Okay.
So.
No, Nora, the question is that, can a body be said to be in motion when its speed or velocity does not change? Yes or no?
Yes.
First, then you explain. Yes. Okay, yes, explain.
Because like a body can be moving at a particular pace without changing.
Without changing what?
Its speed.
Okay, that's what Nora says. Nora is saying that yes, a body can be in motion when its speed does not change. I'm not saying it's correct, but more views. You are 10 here. More views. Can a body be said to be in motion when its speed does not change? Benedict, oh, speak. Okay, so yes, a body can be in motion when its speed is constant. Okay, so in long distance events, when the whistle goes, athlete starts the journey of the race. You see them moving some very good athletes can move in such a way that they can maintain their speed, constant speed. So a body can be in motion, but its speed can be kept constant. But the proof of a body being in motion that its position must change. So motion is change in the position of a body, okay, with respect to time. Change in the position of a body with respect to time. So let's, in motion, we have different types of motion. One of it, types of motion, one of it is
Random.
okay, random motion. So somebody has given us one example of motion, random motion. 2,
Circular.
Circular motion.
circular motion. 3,
Rotational.
rotational motion. Okay, I'll later ask questions. Rotational motion. 4.
Rigid motion.
Periodic.
What?
Rigid motion.
Rigid. A rigid motion. Rigid motion. Let me indicate that somewhere on the board, because whoever said it will explain.
Okay.
Types of motion.
Rectilinear
Linear
motion.
motion.
Rectilinear or
Linear.
rectilinear or linear motion. Is that all?
Periodic motion.
Periodic or
Uniform motion.
no, periodic or oscillatory or oscillatory. There is another motion which also means
Translational.
vibrational motion. Somebody is talking
Translational motion.
translational motion. Some of them are a resemblance of what has been mentioned. Then we also have projectile motion. Projectile motion. Then we have simple harmonic motion. Simple harmonic motion can also be seen within periodic or oscillatory motion. In fact, these are few of the types of motion. Now we'll pick just a few for the sake of what we are going to do to understand what is it. Class, what is rectilinear motion? What is rectilinear motion? I have 12 of you.
So let me try.
Okay, try.
It refers to the movement of an object along a straight line.
So it refers to the movement of an object along a straight line. Yes. Yes. What is circular motion? Please, I hope you are writing. I may not write everything. So when it is defined, try and then put down. Who, Junior? Okay. Junior, go ahead.
It is a motion of a body about a curved path or axis in which the axis lies outside body.
Come again.
It is a motion of a body about a curved path or axis in which it lies outside the body.
The axis lies outside the body. More views. More views.
Okay,
on
sir.
Sir, this is a motion along
Marian.
a circular path. This is motion along a circular path around a fixed center.
Okay, the motion of a body along a circular path around a fixed
center or point.
Or a fixed point. Last contribution on circular motion. Last contribution on circular motion. Okay, that's it. That's it. Now, you made mention of rotational motion. What is the difference between circular motion and rotational motion? What's the difference between circular motion and rotational motion?
Sir,
Yes.
rotational motion is a type of motion that the body spin around its axis, its own axis.
Example, can you give me practical situations or application of rotational or spinning motion?
Okay. Motion of the earth.
So motion of the earth around the what?
Its own axis.
Around the what?
Axis.
Okay, so look at something. Good. You see, the earth rotates, the planets generally rotate around the sun. But as the earth rotates around the sun, it also rotates, okay, on its own axis. Okay, I don't know if, gentlemen, if you have played with snail shell before. If you cut a snail shell and then you have its pointed edge, when you spin the snail shell, it will rotate on its sharp edge. That is the fixed point. Or yes.
So rotation is spinning in one place, and the circular is moving around something.
Exactly. So rotation or spinning motion, the body must rotate at one place. Okay. But circular is about moving around another body. So that's it. The earth rotates as that's a circular motion around the sun. But the earth also rotates around its own axis. Are we okay? Somebody made mention of rigid motion. What is rigid motion? Rigid. Whoever made mention of rigid motion, can you explain what rigid motion is?
Okay, sir. That is a motion of solid body where the relative positions of all points within the object remain unchanged during the motion.
Okay. Rigid means solid or hard. Okay. All right. So the famous ones are what? In physics, we'll be treating linear motion or rectilinear motion. We'll also be treating circular motion, rotational motion. We'll be looking at periodic or oscillatory motion or vibratory motion. We'll also be looking at projectile motion and simple harmonic motion. So linear motion, the motion of a body along a straight path, which is also the same as rectilinear and translational. Okay. When a body moves from one point to another, it covers a distance. So a body starting from point A changes position to point B. Okay. The interval between point A and B is said to be the what? The interval between point A and B is a what?
Distance.
The distance covered. So how then would you define distance? How would you define distance covered by a body?
Let me try.
Okay, sir.
Okay.
It is
The total length of a path traveled by an object.
The total length of a path traveled by an object. More views.
Sir,
No,
it is the
you are not
interval.
talking.
It is the interval between 2 points.
The interval between 2 points. Yes. So note that distance can be so wide or large or long, and can equally be so small or short. A distance covered is basically the interval between 2 points. It can be so large, it can be so small, but it's a distance. All right. So when a body is said to be in motion, it will cover a certain distance within a given time period. You see, when we talked about motion as changing the position of a body within a certain time interval, when I'm starting a journey and I'm beginning from point A, because I have not moved, the time is 0. Now, when I move from a point A to a point B, it will take a certain time to cover this distance A to B. Okay, so let's assume the time taken to move from A to B is T. So in covering the distance AB, it took a certain time interval. The time interval is delta T is subtracting 0 from the final time. So T minus 0. So it means it will take a certain time T to cover a certain distance. Is that okay? Is that okay?
Yes, sir.
In linear
Yes,
motion,
Please, can you go over it?
okay. You see, if you move from your dormitory to the classroom, just as you are about to start moving from the dormitory to your classroom, at the dormitory, because you have not moved, you have the time you have covered is 0. Now, when you start moving, climbing, descending down the staircase, walking along the road to your classroom, won't it take a certain time before you get to your classroom?
Yes,
Won't it take a certain time before you get to your classroom?
it
It
will.
will.
So the distance you would cover from the dormitory to your classroom would also happen within a certain time interval, and that is the time T. So we define distance as motion as the change in position of a body within a certain time interval, meaning that it will take a certain time for you to move from your beginning location to a final location. So motion is done within a certain time interval. Are you okay?
Yes.
Yes, sir.
Let
yes,
us also understand another thing. Apart from distance, we must also understand displacement. Displacement. Can somebody share with us what displacement is? What is displacement? Yes, somebody is not talking. Let me call those quiet ones. Emmanuel Jones. Jones, you are not talking. Jones, you are not talking. iPhone, you are not talking. Lawrence, you are quiet. Matthew. Those names I mentioned, who wants to share with us what displacement is? What is displacement? Okay,
Displacement is the shortest distance between initial and final position.
Shortest distance between initial and final position. Anyway, that's what Lawrence has to say. More views. More views. Benedict.
Displacement is distance in a specified direction.
So distance in a specified direction. More views. Hello.
Sir, displacement is the
Go ahead. Yes, go ahead.
Displacement is the change in position of a body in a particular direction.
Change in position. Okay,
of a body.
fantastic contributions. So let's see. I moved from a point A, go to a point B. Let's assume that A is your starting point. Distance covered is measured from a point of reference. or a starting point. So point A is the starting point. So you move from point A to B. A to B is equal to 10 kilometers. Then from B, you moved to a point C. Look, A to B, this is the direction. Then B to C, this is how you moved. So this is the point C. Let's calculate the total distance covered by the body. What will be the total distance covered by the body in moving from A to B and B to C? C, from B to C is 4 kilometers. So class, what will be the total distance covered by the body?
14 kilometers.
14 kilometers. What is the displacement? Class, what is the displacement? The total distance covered is 14. What is the displacement? All right, you are not talking. I'll arrest you. Hey, who is answering? Who is trying? Who is trying? What will be the displacement?
0 kilometers.
Sorry.
4 kilometers.
Okay. Okay, more
Yes.
trials.
6
Nora,
kilometers.
6 kilometers. Jones is giving us 6. Okay. All right, let me also come in. You see, when it comes to distance, distance is the total length covered by a body. So we are looking at the magnitude of the total length covered by the body. So A to B, 10. The same body, B to C, 4. So the total distance would be 14. Now, total displacement. You see, in moving from A to B, it is like moving along the positive x-axis. Positive x-axis, so plus 10. When the body moves from B to C, it is like moving in the opposite direction. Okay, so minus 4. So when you add plus 10, positive 10 to minus 4, you have 10 minus 4, which is 6. Now, what it means is that in displacement, we take note of the direction of the body. Whereas in distance, we care about the direction. All that we are interested in is the total distance covered by the body. Class, is that okay?
Yes, sir.
So displacement is distance covered in a specified direction. So class, another question to the house. If the body moves from A to B is 10 kilometers, and the body moves from B back to A, what will be the total distance? The body moved from A to B and B back to A. What is the total distance covered?
20 kilometers.
20 kilometers. Let me hear contributions of all of you. What then will be the total displacement?
0 kilometers.
0 kilometers.
Go, 0. Okay, so displacement, somebody defined displacement as change in the position of a body. Yes, displacement is position. So look, I move from A to B and from B back to A. My current position, what is my current position?
10.
No, listen, I move from A to B and B back to A. What is my current position?
Yeah.
What's A? Okay, so what is the distance between my current position and then and then myself. What is the distance between my current position when I move back to A and the body? What's the distance?
10.
You are not
20
following.
kilometers.
You listen to
10.
the question. Listen to the question again. I move from A to B. So it's like A, B, this is the direction, A to A, and B back to A. What is my current position?
A.
I'm at A. So the question is
Yeah.
that, what is the difference between my starting position and the body, myself?
20 kilometers.
20.
No.
0 kilometers.
0. So the position is at A. And once the body's position is at A, the displacement is 0.
So you said distance.
No, listen. As for distance, we have repeated that. We said the total distance covered will be 20. Okay. But I'm talking about, you see, I move from A to B and B back to A. Okay. What is my current position? I'm at A, isn't it?
Yeah.
Yes, sir.
Yeah. So what is the distance or the difference between my current position and myself?
0.
0. There's no distance between the current position of the body and its starting point. 0.
Yes, sir.
So that is why displacement is also change in position of a body. Now, if direction does not change, if the direction of a body does not change, distance covered is the same as displacement. So from A, I move from A to B. A, B, this is 10 kilometers. Then move from B, look at the direction, to C. C is also 5 kilometers. What is the total distance covered?
15.
50 kilometers.
What will be the position or what will be the displacement?
15 kilometers.
15, because the direction does not change.
Okay.
So
Yes, sir.
if direction does not change, distance covered is the same as what? Displacement.
Displacement.
Are we okay?
Yes,
Yes,
sir.
sir.
Is displacement important?
Yes.
How is it important? How is displacement important? You said displacement is important, and I also agree with you. It is important. But how is it important?
It shows the distance in the direction.
It shows the distance and the direction.
Yeah.
Let me try.
Okay, more ahead. Go ahead.
Okay, displacement tells you exactly how far and in what direction an object has moved from its starting point.
So displacement gives us the total distance to be covered, but it has an added advantage. The added advantage is that it also helps us to identify direction. Let me give a practical application. If I ask you to direct me to your house, and then your response is like, oh, my house from the lorry station, go a distance of 500 kilometers. Okay. If I just say go travel a distance of 500 kilometers, would that help? Would that alone help?
No, sir.
It won't help because now 500 kilometers where? We do station 500 kilometers. Where am I going to pass? So when you add direction, it changes the distance given to displacement. And adding the direction would enable you identify the exact location. So displacement enables us to determine both the total distance to be covered and then the direction as well. Nora, are you okay?
Yes, please.
All right. In our study of linear motion, a body in motion cannot have zero speed. Is that possible? A body is said to be in motion and its speed is zero. Is that possible, class?
No, sir.
No.
No. You cannot have zero velocity. If you have zero speed or velocity, then it means you are at rest or you are stationary. If you are stationary, it also means that you are not moving. Class, are we okay? So,
Yes, sir.
when a body moves, it can exhibit, it can have, the moving body can have speed or velocity. So let's look at how to identify or calculate the speed of a moving body. So speed. In dimensional analysis, we saw that speed is equal to what?
Distance over time.
Distance over time.
Distance covered. Distance covered
What?
over what? The time taken. Time taken. So practically, if Nora claims to have speed than Benedict, then how do we justify that truly Nora is speedier than Benedict? How can we justify that one person is speedier than another body? Nora, if you claim to be speedier than Benedict, how would you prove? Nora, over to you.
So they can like make both of us run at the same time, and then they'll see how fast, how far I was able to go within which time, and like yes, and the same thing for him.
Okay,
Sir, please,
Benedict.
what was the question?
The question is that if Nora claims to be speedy than Benedict, how can Nora show that truly he has speed than Benedict? That's the question.
Okay, so sir,
Mhm.
so you
What
run
will
the
you do?
same distance and compare the time. Like both of us will stand at a fixed point and run. So if you finish in less time, you are faster.
Exactly. So Nora, your answer is also correct, but I think he has explained it a bit into detail for us. Okay, so I'll give both of you the same distance to cover. So in 100 meters, what we often do is that we give athletes a distance of 100 meters or the oval, and then they all start from a common point, the same point. Then we compare the time taken by the athlete to finish the same distance. If one person finishes the race within a lesser time than the other person, how do we conclude? Or how can we conclude? If one person finishes the race within a lesser time than the other, how can we conclude?
So you are faster because you took less time.
Exactly. So distance, speed is equal to distance covered over the time taken. Okay. Usain Bolt then was said to be the fastest person on earth. Why? Because the whole world, Usain Bolt could finish 100 meters within a lesser time than anybody else, even though he never competed with me. Even though, and I said, you say what never competed with me. So yes, so me. Before you can be declared as the world's fastest person, he must compete with everybody.
Yes, sir.
He could complete 100 meters within 9.6 seconds. And nobody can do that apart from him. And so he was crowned the fastest man on the planet. So speed is distance covered over time taken. Okay. Now, what is velocity? What is velocity?
Is it a formula?
How would you define velocity? How would you define velocity before we look at the formula?
It is the time rate of change of displacement of an object.
The time rate of change of displacement of an object. So mathematically, velocity.
So I have another definition.
Go ahead.
Is the speed of an object in a specific direction.
So change in the speed of an object in a specified direction. Okay, it can also be said to be the change in the speed of an object in a specified direction. If you are bringing speed, then you have to bring the direction. Or velocity is also the rate of change of distance in a specific direction with respect to time. Listen to it attentively. The rate of change.
Displacement.
The rate, the rate of change of distance in a specified direction with respect to time. With respect to time. Then it can also be defined as the rate of change of displacement with respect to time. The rate of change of displacement with respect to time. Please know the difference. The difference is that if you are talking about displacement, you don't bring direction. The direction is embodied within the displacement. If you are bringing change in the rate of change of distance, then you must bring in a specified direction. Have you noticed the difference?
Yes, sir.
So, and then the other definition I gave, change in the speed of a body in a specified direction. These are the different ways of defining
Sir, please, can you also say
velocity.
Sir,
I'm listening. Can you also say
is the time rate of displacement?
You see, the time rate of change of displacement with respect to time. The time rate of change. If you talk about rates, it doesn't automatically refers to time. Okay, the time rate of change of displacement with respect to time. So
but sir, please, I brought in time.
Pardon?
Please, I brought in time.
Come again. Say it again.
The time rate of displacement.
Oh, okay. The time rate of change of displacement. The time rate of change of displacement, rather. Okay. All All right. Note that speed and velocity have the same dimension. We've done dimensional analysis. Okay. They have the same dimension, and they also have the same what? SI unit. That is why we're talking about limitations of dimensional analysis. Dimensional analysis does not explain whether the quantity is vector or scalar. Okay.
Okay.
All right. Then the next thing to look at is acceleration. 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 Nora, what is acceleration? What is acceleration? When a body is said to be accelerating, what does it mean? Nora.
Acceleration is the rate of change of velocity in time with respect to time.
Rate of change of velocity with respect to time. Okay, so more views.
Acceleration is how fast the speed or velocity of an object changes with time.
How fast?
The speed or velocity of an object changes with time.
Okay, so in your definition, you said how fast?
Yes.
Acceleration can also be how slow the speed changes. So acceleration can be said to be how the speed or the velocity of a body changes with respect to time. The how can be so fast or can be so slow. If you say how fast, then you mean every acceleration must be such that the speed must change so fast, but it can also be so slow. Are you okay?
Yes, sir.
So we define acceleration as the rate of change of velocity or speed with respect to time. You mentioning the rate talks about how, the rate of change of speed or velocity with respect to time. Example, you see, if you are stationary, if you are standing at one place, your speed is 0. When you begin walking, your speed is increasing. When you begin running, your speed is increasing. And so we say you are accelerating. Okay, what is the change? The change in your speed is that it is increasing speed with respect to time. Then when a body is also speeding and wants to stop, the who drive a beer or the top speed of a so no break but no there will be accidents. So nobody does that. That would be top speed. Who person we no break 16 now they will break. No. So if you are moving at a top speed, you will start braking, reducing speed gradually till you come to a stop. So in this case, how is the speed changing? The speed is decreasing with respect to what? Time. Are we okay?
Yes,
And that is also an acceleration, but we term that said acceleration, deceleration or retardation. Are you okay?
Yes,
So
sir.
it means that acceleration can be positive. Acceleration can also be negative. But if we have a negative acceleration, we describe that as deceleration or retardation. Are we okay?
Yes, sir.
So acceleration A as change in speed or velocity. Change in velocity or speed with respect to time, the time interval. Example, Benedict is stationary. Matthew, leave my board alone. Benedict starts from rest. Benedict starts from rest. If you are set to start from rest, then it means your initial velocity is 0.
Yes.
At a time interval of 20 seconds, his final speed is 50 meters per second. Determine the acceleration of Benedict. Determine the acceleration of Benedict. Determine the acceleration of Benedict. Can you try?
Yes.
Start with
2.5.
Come again.
2.5.
Okay. So A is equal to change in velocity over the time interval. It can also be change in time, but the starting time is 0. So when you subtract the final time, the starting time from the final time, it will be equal to the same time. That is why we don't talk about delta T. So final velocity 20 minus initial velocity 0 divided by the time interval, which is, the final velocity is 50.
Yes.
Divided by a time interval of 20. So this is giving us 2.5. What is the SI unit? What is the SI unit?
Meters per second.
Meter per second squared. Okay. Another question. Nora is moving at a speed when the direction does not change. Speed is the same as velocity. Nora is traveling at a speed of 100 kilometers per hour. On your car. And decelerates. So she comes to a hello.
Sir, please, you wrote 1,000 instead of 100.
Oh, 1,000 will do. You're funny, sir. Sir, Nora Danica and decelerates. So she comes to a stop. She comes to a stop in a time interval of 360 seconds. 1. Determine the acceleration of Nora I. or A, in kilometer per hour squared, and B, meter per second squared. I'm giving you 6 minutes for this work. It's 12 o'clock on the dot. Start work. 6 minutes. Have you finished before time? Though I'll give you 6 minutes. If you manage to finish.
Almost.
Okay. Right. Okay, so.
Please, I'm done.
Okay. In kilometer per hour squared. All that you see for A, our speed or velocity is already in kilometer per hour. So it means we must change the time interval into hours. So we have 360 seconds. How do we change 360 seconds into hour? 1 hour is equal to
by.
So 1 hour is equal to 3,600 seconds.
Yes, sir.
So if 1 hour is equal to 3,600 seconds, what will be 360 seconds?
0.1.
0.1.
Yes.
Please, did we all get that?
Yes, sir.
Okay.
Yes, please.
Okay, so the acceleration, which is change in velocity over time, is equal to 1,000. She comes to a stop, meaning her final velocity is 0 minus 0 divided by the time
No, sir.
interval. Pardon?
I think her final velocity is
She
1,000.
Nora
0 minus
decelerated. Nora decelerated rather.
Yes, sir.
Thank you. I thought it was acceleration. So
0 minus
0 minus 1,000.
1,000.
Okay, so acceleration is change in velocity over the time. The change is always final velocity minus initial velocity. Okay, or divided by time. So the final, since she comes to a stop, the final is 0, the initial is 1,000. So this is divided by 0.1. So negative what? Negative what?
Negative 0.77.
Check. That's not correct. When
So
you converted
negative 10,000.
negative 10,000
Yes, sir.
kilometer per hour square. Okay, this is also an acceleration, but acceleration can be positive. It is positive when the speed increases with time, and it is negative when the speed decreases with time. Okay, a negative acceleration is termed a deceleration or a retardation. Are you okay?
Yes, sir.
We are also asked to change that to meter per second squared. Now, you can use the same value to do that. If A is equal to negative 10,000 kilometer per hour squared, let's change kilometer to meter. How many kilometer makes how many meter make one kilometer?
1,000.
So the shortest way of doing this is that this kilo is a prefix, meaning 10 to the power 3 or 10 raised to the power 3. We must do measurement. So I'm replacing the exact value of kilo divided by 1. This is actually 1 hour squared. Okay, and 1 hour is 3,600 seconds. So it means 1 hour squared means 3,600 seconds squared. Because another way, 1 hour squared also means that we have 1 hour times another 1 hour, isn't it?
Yes, sir.
So 1 hour in seconds is 3,600. So another 3,600. So it's the same as 3,600 squared. So we have negative 10 exponent. This is 4. And then this is 3. 7 divided by plus what is 36,000 squared? 36,000 squared.
36,000 squared.
Yes.
There is 129600.
So 1296. I'm coming in. So 12960 and 3 zeros.
Yes, sir.
So divide.
No, sir.
Hello.
6 zeros.
No,
6 zeros.
36 times 36 1296 and then 4 zeros. Yes, check.
So you said 36,000.
36. Oh, okay. 3,600 rather. Sorry. 1 hour is 3,600 seconds. So 3,600 seconds squared. So that's it. So divide 10 to the power 7. And 10 to the power 7 is what? 10 million, isn't it?
Yes, sir.
So divide 10 million by this. What's the answer?
0.77.
So minus 0.771 or negative 0.772.
16. Okay.
It's 1, but I'm running it to 3 dp. Meter per second square. How many of you got this correct? The second one. Show by hands. Show by hands if you got it correct.
Sammy.
Hey, you don't know how to raise up your hand on the page. Nora has done that. So use the emoji to do that. Okay. All right. Okay, so that's how to do this calculation. Okay. Now note that for acceleration is always a change there must be a change in the velocity or speed for the body to be said to be accelerating. There must be a change. That is why in mathematics or in physics, acceleration A is equal to delta V, where delta V is the change in velocity. If a body's velocity or speed does not change, acceleration is 0. Are you listening?
Yes, sir.
If a body's speed or velocity does not change, acceleration is 0. So if we are talking about numerical value of acceleration, then the speed or velocity of the body must change. So acceleration is defined as the change in velocity or the speed of the body, meaning that we cannot say that acceleration is velocity over time. Change in velocity over time. Class, are we okay?
Yes, sir.
Yes.
Then let's look at graphs of motions. Graphs of motions. Graphs of motions. We can put
come again.
Graphs of motions. That's the next subtopic. Graphs of motion, meaning we are representing motion on a graph.
Okay.
Sir Francis. Sir Francis, you are welcome. Graphs of motion. Graphs of motion, the whole class.
Graphs of motion.
Wherever you find yourself, I want you to respond. Graphs of motion.
Graphs of
motion.
Okay. Class, let me pick this call within a minute and get back to you, okay?
Okay.
Also.
So in graphs of motion, we are representing these motions, okay, we described earlier graphically. Okay. Hello. Okay, sorry, class, sorry for that interruption. So the first graph of motion I want us to consider is displacement against time graph. Displacement dash time
Distance
graph.
time.
Please, this is also the same as distance against time. Okay.
Okay.
Displacement time or distance time graph. So here we plot the vertical axis of the graph. We go for displacement, and then the horizontal axis will go for time. You see, in graph work, we always plot the dependent variable. Dependent variable on the vertical axis and the independent variable. Independent variable on the x-axis. What do we mean by dependent and independent? You see, time does not wait for us. Time is always going. Today, what's today's date?
12.
12th of January 2026 will never be seen again. It is always going. You will never meet 12th January 2026 again. So time will not wait for you. You must do everything you need to do within the time. Marty, please mute yourself.
Okay, thank you, sir.
So because time is an independent variable, or the time it doesn't wait for any man. But displacement or distance covered will depend on time. So when time is 0, you have covered 0 distance. When time increases to 5 seconds, what is that distance or displacement you have made? Okay, so as time changes, the displacement or distance covered by a body can change. So we always plot in graph works, we always plot the independent variable on the x-axis. So here time will be placed on the horizontal because it's an independent variable. And then the distance covered, which depends on time, would be placed on the vertical. In graph work, the quantity displacement is represented by a small letter s. So velocity, which is change in displacement over time. S means displacement. So in kinematics or linear motion, Small letter s is equal to displacement of a body. Please, are we fine?
Yes, sir.
Now, if a body is moving such that its distance in a specified direction increases equally within equal time interval. So example, when at t is equal to 0, displacement is 0. At t is equal to 1, displacement is 2. At t is equal to 2, displacement is 4. At t is equal to 3, displacement is 6. 4, 8. 5, 10. What is happening? The displacement of the body is increasing in equal intervals with respect to time as well. Meaning, at every 1 second, the body's displacement changes by 2 meter. 2 meter. Please, are we okay?
Yes, sir.
Yes.
When you plot such a motion, this is the point t is equal to 0. Nora, are you there?
Yes, please.
So 1, 2, 3, 4, 5, 6. Then the displacement, the minimum displacement is 0, maximum displacement is 10. So we have 2 here, 4, 6, 8, 10. So let's plot such a graph. At t is equal to 0, displacement is 0. So this graph will start from the origin. At t is equal to 1, displacement is 2. This is where the value would be. At t is equal to 2, displacement is 4. At t is equal to 3, displacement is 6. Displacement is 6. T is equal to 4, displacement is 8. T is equal to 5, displacement is 10. Clearly, t is equal to 6, displacement will be 12. Okay. Now, when you join the points, let's join the plotted point. We'll have a straight line starting from the origin. Let me use a straight line to do this. We call this kind of motion uniform velocity motion. This kind of graph is termed as uniform velocity motion. Why is it uniform velocity motion? You see, do you know how to find a slope of a graph?
Yes, sir. Gradient.
The slope or gradient. I'm going to give you different slopes to help me determine determine it. So, Nora, are you there?
Yes, please.
Yours is this first one. I've chosen the third point and then the origin. Benedict.
Yeah.
Yours is this red one. I've chosen the third point and the fourth point. Help me find this. Andy, are you there?
Yes, sir.
Okay. Andy, yours is that the fourth point and this point. And the last point. Anefi. Uncle Anefi.
Yes, sir.
Yours is this bigger triangle. And the rest of you must pick the same graphs to find. So, Nora, you are finding the slope of this one. Yours is this one, number 1. Benedict, yours is number 2. Andy, yours is number 3. Anefi and the rest of you, yours is number 4. Find the slope of 1, 2, 3, and 4 for me. Start work.
Sir, I'm done with the 4.
Anefi, who has done? Who is through with the fourth one?
Sir, please, I'm done with mine.
Okay, then attempt all the others. If you are done with the 4, attempt 1, 2, 3 as well. All of you. Okay, just attempt all the numbered graphs and let's see what you have.
Sir, all the answers are the same.
Yes.
Hello?
Sir.
Nora. Nora.
Yes, please.
What did you get for your work set? Yours is the slope will be the change slope or the gradient is equal to the change in the vertical The vertical is displacement, right?
Yes, sir.
So delta S over delta T.
X. Yes.
Okay, the horizontal is time. So no rest is I ask you to work this out. The first, okay, this and this one. So for this 4 minus 0, 4 minus 0 divided by the change in the horizontal 2 minus 0, isn't it?
Yes, sir.
Yes, please.
So we have 4 over 2, which is 2. What is the unit? What is the unit of the displacement?
Meters per second.
So the displacement is in meter, and then the time is in seconds. So meter per second. Okay, those of you who calculated for the slope of the 2, what is your answer?
Sir.
What those of you who worked on the second graph, the second slope, what is your answer? Is it Benedict?
Yes, sir.
Sir.
What's your answer?
It's the same thing.
You have the same value. Andy,
Yes.
what did you get? Andy, what did you get? 3.
2 meters per second.
You got what? Andy, what's your answer?
I got 2.
Okay, Anefi. Anefi and your group. What did you also get?
Sir, please, I had 2 meters per second.
Good. See, on this straight line graph, on this graph, the slope is the same. When something is the same, what is the adjective that can be used? When something is the same, it's what?
It's
Equal.
It's equal. More adjectives. Equal.
Spa.
Pardon?
It's spa.
It's spa. More adjectives.
Sir, it's equivalent.
No, if something is the same. Okay, no, equivalence, there can be some slight changes. But the adjective you can use to also describe is that they are uniform. They are uniform, isn't it?
Yes, sir.
You can also say that they are constant. Okay. So for a displacement time graph, the slope would give you the velocity. That is why you have 2 meters per second. Meter per second implies that it is velocity or speed. So note that the slope of a displacement time graph, the slope or gradient of a displacement dash time graph would give you is equal to the velocity. Okay, so if it's a displacement time graph, the slope or the gradient would give you velocity. If it's a distance time graph, the slope would give you what?
Velocity.
No, if it's a distance time graph, the slope will give you what? Speed. Class, are you there?
Yes, sir.
So
Yes, sir.
note that the slope of a distance time graph is equal to the speed, whereas the slope of a displacement time graph is equal to the velocity. Are you okay?
Yes, sir.
Yes, sir.
So sometimes we'll give you a graph, displacement time graph, or distance time graph, and ask that calculate for the speed of the body. And because you see, when you calculate it, you realize that the velocity is the same no matter the slope taken. You all had the same value. And because it is the same, that is why we say that this is a uniform velocity motion, meaning that its velocity is uniform or constant along the slope, along the straight line. Okay, so we call this a uniform velocity motion. A uniform velocity motion. Why? Because the velocity is uniform or is constant or is the same along the straight line. Are we okay?
Yes, sir.
Yes, sir.
All right. Now, let's also have a different scenario. The scenario is this. We have time / seconds, and we have displacement / meter. At time t is equal to 0, displacement of the body 0. At time t is equal to 1 second, displacement maybe 5. At time 2 second, displacement 7. At time 3 second, displacement 12. At time t is equal to 4 second, displacement 13. At time t is equal to 5 second, displacement 20. Okay, so when we also plot such a graph, the independent variable is always on the x-axis, and that will be for time times second. Then the dependent variable, which is the displacement, is here. Our times ranges from 0 to 5. So 1, 2, 3, 4, 5, 6. And our times start from 0 and ends at 20. So let's increase our vertical axis a little bit. So if we make it 5, 5, we have 5, we have 10, 15, 20, 25. You see, when you plot, the first one will be here. Time 0, displacement 0. Then the second one, when time is 1 second, displacement is 5, you'll be here. When time is 2, displacement 7, it would increase a little bit. When time is 3, displacement 12, it would increase perhaps to this. When time is 4, displacement 30, small increase. When time is 5, displacement 20, such a gargantuan change. Okay, now when you plot such a graph, you get a curve. A graph is a curve. Now, can you help me find the slope of this graph? Can you help me determine the slope or the gradient of this graph if you have a curve?
Yes, sir.
Nora, Andy, Anefi, Kelvin, Marian, Jones, Gerard, Matthew. You see, if you have a curve, for a curve, you can't have a uniform slope, right?
Yes, sir.
If you have a curve, unlike a straight line, here you can't get a uniform slope. You can only determine a slope within a given time or at a point. Example, I can find a slope at time t is equal to 2 seconds. And we call this kind of slope as instantaneous slope. So within an instant, maybe 2 seconds, and I decide to find the slope which represents the speed at a time 2 seconds. So because, and 2 seconds, you see, the slope, which is the speed for 2 seconds, will be different for the slope at 3 seconds. So on a curve, you can only find slope within an instant or at a given time. So we call this a non-uniform velocity graph. A non-uniform velocity graph. Please, did you hear that?
Yes, sir.
Yes.
This is a non-uniform velocity graph. Non-uniform because the velocity which represents the slope wouldn't be the same. It will be different at different times. So it is not uniform. The reason why we have non-uniform. Velocity because for every displacement time graph, the slope will represent velocity. So this is a non-uniform velocity graph.
Sir,
Are we okay?
the question.
Ask, I can ask.
The question.
Okay, ask.
Sir, please, so if they said find the slope of the graph and it's non-uniform, what will you write there?
So as I said, for a non-uniform, you can't determine. You see, in the first one, when you calculated, you had the same value, meaning the slope is the same no matter the time. Okay. When it's non-uniform, you can only find the speed which represents the slope at a given or within a given time. So you can only find instantaneous velocity. Instantaneous velocity. Instantaneous velocity means velocity within a given time. So if I choose a particular time, maybe at 1 second, what is the velocity? When I get that, I'm determining velocity within a time of 1 second. If I pick maybe at time t is equal to 2 seconds, calculate the velocity. Here, I'm determining the velocity within an instant of 2 seconds. So under a non-uniform velocity graph, you can only find instantaneous velocity, which represents the slope. Are you okay?
Yes, sir.
Nora, you are not talking. Are you okay?
Yes, please.
So we have a uniform velocity graph and a non-uniform velocity graph as well. Now, if we have this, I'll keep quiet here and then you tell me what this means. We have a displacement time graph, and the graph is like this. This is s/meter, t/second. Class, if you have a displacement time graph and the graph looks like this, what does it mean? What does this graph mean? Yes. Anybody? We have a displacement time graph which is like this.
What does it mean?
What does the graph mean, or what does it represent? Anybody?
I have the idea, but it's not.
From Benedict to Nora.
So like
every second has the same displacement.
Jones, Emmanuel Jones, I will not buy it. Yes, more views, more trials.
It feels like the displacement is like constant.
The displacement. Nora is saying displacement is constant. More views.
Sir, please, the object is not moving.
The object is not moving. Why do you say that? Graph way, this is similar to them. Let's add values from 0 to 5. Then 5 to 10. This is 10. When we were in DHS, during long distance events, girls, for instance, 3,000 meters, the whistle or the gunshot will go, and they will start with a very huge speed, or the speed will be so great. Then they will cover some distance for a while, and then from there, because they are tired, they cannot move again. So when the journey started, the person is here. Maybe it's at t is equal to 0. The person managed to move to this point. Then time continued to increase, but the position of the body or the person is at the same distance. And when the body is moving such that its position is the same as the time changes, what does it mean? It means that the body is stationary, isn't it?
Yes, sir.
So this is a graph of a stationary body. A graph of a stationary body, or a graph of a body that is at rest, or a graph of a body that is at rest. The body's position is the same. Please note that a stationary body, okay, is only shown in displacement or distance time graph. So the moment, when you calculate the slope, what will be the value of the slope? What will be the value of this slope? Can somebody help? What will be the value of this slope?
This is 0.
Is it a question or answer? Ado.
It's an answer.
And then it is 0. Lawrence, are you there? The slope of this body is 0. If the slope is 0, what does it mean? Class, if the slope of a displacement time graph is 0, what does it mean?
The object is not moving.
Or
it is stationary.
Yes, It's not moving, it's stationary, but what else can you say if the slope is 0? What else can you say if the slope is 0? You've forgotten something. What does the slope?
His velocity is 0.
Velocity is 0. I said if you have a displacement time graph, the slope is equal to the velocity. So if the slope is 0, it means that the velocity or the speed is 0. Let's not talk about speed because speed will certainly be for distance. So here, when the slope is 0, it means the velocity is 0. And if the velocity is 0, it means the body is not moving, it's at rest. Are you okay?
Yes, sir.
So those are the key elements or ingredients you must understand. So simple, but you must understand certain things. Now, we've just seen that if you have displacement time graph and the graph is like this, the graph is like this. What does it mean? What does this mean? What does this graph mean? We've just done that. So what does this graph actually mean?
A uniform velocity motion.
Uniform velocity motion, or so a body is said to be in a uniform velocity motion. It covers equal distances within equal time interval. Please, if you haven't written that, do that. A body is said to be in a uniform velocity motion if it covers equal distances within equal time intervals. Okay, when it covers equal distances, a body is said to be in a uniform velocity motion. In a uniform velocity motion, if it covers equal distances within equal time interval. Okay, so in the example we cited, when the time was increasing by 1 second, the body was covering 2 meters, 4, 6, 8, 10, meaning that it was covering equal distances within equal time interval of 1 second, 1 second. Another definition for uniform velocity motion is that uniform velocity motion is that it is the motion of a body. It is the motion of a body whose rate of change of displacement, whose rate of change of displacement with respect to time is constant. Is the motion of a body whose rate of change of displacement with respect to time is constant. Are we okay?
Yes, sir.
No, sir.
Is the motion of a body whose rate of change of displacement with respect to time is constant. Rate of change of displacement with respect to time is constant.
Thank you, sir.
And what is rate of change of displacement with respect to time? What is it?
Velocity.
That's velocity. So meaning that when the body is moving in that manner, it has a constant velocity. As the assignment to you to think about, which I'll ask tomorrow, is this. What does it mean if we have such a motion? If we have this kind of motion, yes, it's a displacement time graph. It's a displacement time graph. So S/meter, T/seconds. The body moves from the graph is like this. The graph is like this. Crosses the time axis and comes here. What does it mean? That is your assignment to be submitted tomorrow. You have to think about, you answer. It's a displacement time graph. Okay, the graph starts from a higher value of displacement, then comes to T, and then cross to the other side. What is the meaning of this graph? So whilst you sleep, you eat, you drink, you play, be thinking about this graph. I've explained to you what this one is, what this one means. You have to be thinking around this to answer tomorrow. Are you okay?
Yes, sir.
Ladies and gentlemen, this is where we draw the curtains on today's meeting. We'll end here. I'll certainly upload the video. We'll continue. Tomorrow we'll start at 8. Don't forget. All right. Remind your truant colleagues to be joining us. We have a lot of you registering, but the attendance hasn't been encouraging. So remind them to do the needful. Okay. All right. So I'll see you tomorrow. Bye-bye.
Bye, sir.
Bye.
All right.
Bye.
Bye, Nora. Jones.